Okay, so this video is going to be on intro to significant figures. You should have already copied down these notes in your notebook. Now, significant figures, it's used as a way to express which numbers are known with certainty and which are estimated. For example, when you measure something with a ruler, you can always measure it like if it goes to the tenths place and you're in between you're measuring something that's in between 4.1 and 4.2 inches. There's an estimated digit. If it falls in between, it could be 4.15. That last digit will be an estimated digit. And our whatever we use to measure things is kind of limited, and that's what it has to do with significant figures in a measurement. So what are significant figures? They're all the digits that are known plus the last digit that is estimated in any kind of measurement that we do. Now there's rules to if numbers are significant or not. Now the first rule says that all digits 1 through 9 are always significant. So if you see the number 129, all those are non-zero numbers, so they would all be significant. So that would be 3 significant figures. And we shorten that up and call them sig figs. So all non-zero numbers are significant always. Okay, the zeros is where it gets a little bit tricky. You're just going to have to memorize these notes and keep referring back to them. Embedded zeros between significant digits are always significant. What that means is captive zeros, zeros that come in between two non-zero numbers. So if you see this, 5007, you got a non-zero number, and then you got 2 zeros in between. And so we know that the 5 and 7 is significant. We need to determine if those 2 zeros in the middle are significant. Since they're embedded, they come in between 2 significant digits, they would be considered significant. So the total significant figures would be 1, 2, 3, 4. So we have 4 sig figs. Now another rule says trailing zeros in a number are significant only if the number contains a decimal point. So if we have number zeros that come after non-zero numbers, only significant if there's a decimal point. So if we look at 100, the only non-zero number is 1. Then after that, you got zeros. You got 3 zeros. So are they significant or are they not? The rule is if there's not a decimal there, they would not be significant. But since there's a decimal there, that one decimal, it makes all 3 of these zeros that come after a non-zero number significant. So that would be 4 significant figures. And then if we have 3600, we got our trailing zeros here at the end, these two. The only way they're significant is if there's a decimal. There's no decimal in that number, so that would be just 2 significant figures. Okay, leading zeros at the beginning of a number are never significant. So if you have zeros that come before non-zero numbers, like these 3 right here, those are never significant regardless of the decimal or not. Okay, since all 3 of those zeros come before the 25, since they are leading zeros, they never count as being significant. The only significant digits would be this one and this one. So that would be 2 significant figures. Zeros following a decimal significant figure are always significant. Example, if we look at this first one, this number, these zeros here will not count because they are leading zeros. Even though there's a decimal there, leading zeros never count. However, this last 0 would count just because there is a decimal in there. So that would be 3 significant figures. And then our last example, number 5 here, this first 0 would not count because it's a leading 0, but these last 3 would count because there's a decimal there. So that would be 5 significant figures. All right, exceptions to the rule are numbers with unlimited number of sig figs, and that's if you count something like 25 students, we say that's an unlimited number of significant figures, or exact quantities like 1 hour equals 60 minutes, 100 centimeters equals 1 meter. So that's our only exceptions to the rules there. Our significant figures would be unlimited. All right, and why is it important that we know what numbers are significant? Because we'll know how to round our answers. When you get in college, you might have some professors that's going to be real picky about how you show your answers, and they might want you to show it to the correct number of significant figures and to round the correct number of significant figures. So you have to know these rules. Okay, significant figures for numbers in scientific notation. When determining the number of significant figures for numbers in scientific notation, don't look at the exponent, all right? So we're only going to look at, in numbers of scientific notation, is this. We're not going to look at the exponent here, or this times 10 or something. So this first one would just be two significant figures because they're both non-zero numbers. Our next example, 4 times 10 to the 23rd. We just kind of pretend like that times 10 to the 23rd is not there. We'd only have one significant figure because of that 4. It's a non-zero number. And then our last example here, 2.578 times 10 raised to the negative 2. We don't even look at this right here. We only look at this number. It's 4 non-zero numbers that would all be significant, so it would be 4 significant figures. So if we look at these examples, and the answers are already there for you, but let's go over why these are the correct answers. So if I look at 123, they're all non-zero numbers, so they'd all be significant. That's why there's 3 significant figures. Our next example, times 10 to the 4th. We just disregard that, don't look at that. I'll look at only this 9.8000. Remember, these zeros that come after numbers are not significant unless there's a decimal. Since there's a decimal there, those last 3 zeros would all count, so that would be a total of 5 significant figures. Okay, our next example, if I had 0.07080, I know that the 7 and the 8 is significant for sure. And then the captive 0 in the middle is going to be significant because it's in between 2 non-zero numbers. Now look at the first 2 zeros. They are leading zeros. It doesn't matter if there's a decimal or not. They come before numbers. They are never significant. And then look at the last 0. It is significant just because there's a decimal in that number. So that would be 4 significant figures. Our next one there, 40,506. Well, look, I got this 0 is in between the 4 and 5, so it would be significant. This 0 is in between 5 and 6, so it would be significant also. So all of those numbers would be significant. In this case, it would be 5 significant figures. Next, if we look at 22 meter sticks, that is telling you, that's counting something, so that would be unlimited. And next, 98,000. I know that the 9 and 8 is significant because they're non-zero numbers. These last 3 zeros are not significant unless there's a decimal. There's no decimal in there. That's a comma. So they would not be significant. This would only be 2 significant figures. Next, 143 grams. Each one of these numbers is non-zero. So that would be 3 significant figures. And then this next to the last example, if I look, I know the 7 and 3 is significant, but I look at the first zeros. They are leading zeros. They come before non-zero numbers, so they are not significant, so that would only be 2 significant figures. And we look at the last example. It's in scientific notation. I'm going to disregard this part here. It doesn't matter. I only look at this part. I know that the 8 is significant, the 7 is significant, the 5 is significant. This last 0, if there's a decimal somewhere in there, it will be significant, and there is a decimal, so it would be considered significant also, for that's 4 significant figures. Now, if we look at, I'm going to show you a strategy. If we look at a number, if we have 708, now I want to figure out how many significant figures that has. What I'll do sometimes is go and put a line in front of the first non-zero number, which will be right there. Put a line after the last non-zero number, which would be 8. And I know for sure that all the numbers in between those lines is significant because that 0 is a captive 0, it's an embedded 0. So that would be 3 significant figures. All right, if I had 4,500, and I want to determine how many significant figures it has, put a line in front of the first non-zero number, which is a 4, put a line behind the last non-zero number, which is 5. So I know for sure there's 2 significant figures. Now I just check the zeros there. My rules say that if zeros come after non-zero numbers at the end, trailing zeros, they are never significant unless there's a decimal. There's no decimal in there, so that would just be 2 significant figures. Now if we look at that same number though, and say we had 45.00, and I do the same thing again. I'll put my lines, first non-zero number, and then after the last non-zero number. Now I look, and zeros that come after are significant only if there's a decimal. There is a decimal in that number, so those zeros would be considered significant. So that would be 4 significant figures. Now, if I took that same kind of number and did this, now if I'm looking at this number, 0.00450, do the same thing. Put a line in front of the first non-zero number, which would be 4. Put a line after the last non-zero number, which would be 5. And then I look. Now I know according to my rules, leading zeros are never significant. So these 3 are not going to be significant even though there's a decimal. The decimal only goes with these zeros that come after numbers. If there's a decimal, it is significant. And since there's a decimal, the 0 would be significant, so that would equal 3 significant figures, the 4, the 5, and the 0 there. All right, if we look at a couple more, if I had 0.00035007000, and I don't know how many significant figures that has. Again, I'm going to put a line in front of the first non-zero number, which would be 3. I'm going to put a line after the last non-zero number, which in this case would be 7. Now I know everything within my line there is significant, so I'm at least going to have 5 significant figures. The 3, 5, the 2 zeros, and the 7. I gotta look at the leading zeros, the ones that come before. They never count. Those are not significant. These 2 zeros at the end only count if there's a decimal in here. There is a decimal, so those 2 would be considered significant. So that would be 1, 2, 3, 4, 5, 6, 7. 7 significant figures. And then if we look at one more, look at this number. I'm going to go in front of the first non-zero number, which is 6. I'm going to put a line after the last non-zero number, which is 8. And I know that everything in between those lines is significant. Those zeros within between the red lines are significant because they are embedded zeros. The only ones I got to look at is the last 3 here. Are they significant? Well, my rule says that the trailing zeros at the end are only significant if there's a decimal somewhere in there. There's no decimal, so these would not be considered significant. So I would just have 1, 2, 3, 4, 5, 6 significant figures for that number. All right, so what we have to remember is all non-zero numbers are significant. Zeros that are embedded in between 2 non-zero numbers are always significant. Leading zeros that come before numbers, regardless of a decimal, are never significant. And then zeros that come after, trailing zeros or zeros that come after non-zero numbers are never significant unless there is a decimal. All right, now we want to look at how we round numbers using significant figures. When you're rounding, first determine the number of sig figs and then count from the left and round. If the digit's less than 5, the value remains the same. If the digit is greater than 5, the value of the last digit is increased by 1. That's just basic rules of rounding. So if we look at these numbers, and we want to round each measurement to 3 significant figures. I have to remember my rules. Now 87.073 has 5 significant figures. Alright, I need to round it to 3. So I need to go from right to left. I need to cut this off right here. And when I round it, that becomes, it's either 87 point, and the 0 is going to round up to a 1 because that's 7 there. So that would be 87.1, and that's 3 significant figures. So that makes sense. Now if I want to round 4.3621 times 10 to the 8th meters to 3 significant figures, I would, again, disregard this. Right now, 4.3621 has 5 significant figures. I want it to just have 3. I'm going to have to cut it off right here, and that would become 4.36, and it would stay at 6 because there's a 2 after that. 4.36, and then I'd put the times 10 to the 8th, and that would be 3 significant figures. Now, the next one, I want to have 3 significant figures. How can I do that? Well, I know these first 2 zeros don't count as significant. So I need to have 3 significant figures, I would need to cut it off right here. Because the 1 and 5 are significant, that would be 3 significant figures. So then when I round that, it would be 0.0. Both those are not significant. Then 1, 5, 5. You could also put it in scientific notation to round that. All right, next, 9,009 meters. How can I make that into 3 significant figures? Well, I need to cut it off right here. Now, 900 would only have 1 significant figure, so 900 would not be the right answer. But I could take that 9, that last 9 would make that 0 round up, and I would get 901, 0. That has 3 significant figures because the 9, that 0, and that 1 are significant. That last 0 is not significant, so that would be rounded to 3 significant figures. And next, 1.777 times 10 to the third. I want that in 3 significant figures times 10 to the third. I'm going to kind of disregard that for a minute. I need to have this another number to have 3 significant figures. I need to cut it off right here. I want that to be 1.77, but that next 7 would make that 7 round up, so it would be 1.78 times 10 to the negative third. That is 3 significant figures. And then last, 629.55. To make it have 3 significant figures, I need to cut it off right here. The only problem is that 629, that 5 is going to make the 9 round up, and that's going to make it round up to 630. But I have a problem because that 0 there is not significant. That's only 2 significant figures. So what I can do to correct that, remember, if I put a decimal anywhere in there, if I put this decimal at the end, that's the same number. 630 and 630 with the decimal is the same number. I put that decimal in there, it makes this 0 become significant, and that would be 3 significant figures. So if we look at a couple more examples, if I have 527, if I have this number right here and I want to put it in the correct number of significant figures, I'll say I want to have 2 significant figures for this one. There's a couple ways I can do this. I would need to cut it off right here, right? I can't change the number though. To make it I would have to make it have 2 significant figures. I could do this. I could round it up to 5,300, and then the 5 and the 3 significant. Those last 2 zeros wouldn't be, so that would be 2 significant figures. Now sometimes it's easiest for me though, when I'm going to do something like this, is if it's kind of hard about rounding to make it have the correct number of significant figures, what I do is put it in scientific notation and then round it. So I want 2 significant figures. Right there would be my decimal. 1, 2, 3. That would become 5 point, and the 7 would make the 2 round up. So the 2 significant figures rounded, it would be 5.3 times 10 to the third power. So sometimes it's easiest to put them in scientific notation where you can get the correct number of significant figures. So let's say I wanted that same number, 5270, and I wanted it to 1 significant figure. That means I would have to cut it off right here. I could either do it this way. I could say, well, 5270, I could round it down to 5,000. That would be 1 significant figure. Or I could put it in scientific notation and do it that way. I could go 1, 2, 3. I want my answer to that would become 5.270 times 10 to the third. However, I wanted to have one significant figure. I would have to cut it off here, and I could just write it this way: 5 times 10 to the third. And 5 times 10 to the third is the same number as 5,000. So you can always put it in scientific notation if it makes it easier to round a number. And if we look at one more, if I had 0.0004500, and let's say I wanted to round that to 3 significant figures. Well, I know that these first numbers here are not significant, so let's rewrite those: 0.000. Those are not significant, but now I want to round to 3 significant figures: 5450. I leave the last 0 off because now with this number I got 1 significant figure, 2 significant figures. So this last 0 is significant because there's a decimal there, so it would be significant. So that would be 3 significant figures. So my answer would be 0.000450. That would be that top number rounded to 3 significant figures. If I wanted to round to 2 significant figures, then I could do this: 0.00045. Leave that last 0 off. Now that would be just 2 significant figures: 1, 2. Those other zeros in front would not count. And that's how you tell about what numbers are significant, how to tell the number of significant figures, and how to round an answer to a certain number of significant figures. So as you do these worksheets, help one another. You can put the problems on the board to show one another for anybody that's confused.